this is our first video in Module 4. And in Module 4, we'll talk a lot about the coordinate plane, meaning the x and y axis, and graphing points and segments. We'll talk about distances and slopes in this video. And eventually, in this unit, we'll begin talking about quadrilaterals, about rectangles and parallelograms and rhombuses and kites. And that's kind of where we're going in this module. But for this lesson, we're focusing on distance and slope. And there aren't any CCRSM standards that are directly tied to this, but it's preparatory. It'll prepare you for the future lessons in this module. Let's get started. Lesson 3 of Module 4 starts off with a question to find the length of segment AB, where A is the point -2, 1, and B is the point 3, 3. Now, if the segment AB was horizontal or vertical, it'd be very easy for us to count coordinates. But segment AB is not horizontal or vertical. It's kind of at an angle, at a slant. And the hint given to us in this opening exercise is to use the Pythagorean Theorem to find the length AB. Now, the Pythagorean Theorem can only be applied to right triangles. So what I have to do is somehow put a right triangle on the graph, and the most logical one to put is this one right here, this right triangle, because I can then count off the horizontal and vertical distances and then use the Pythagorean Theorem to find length AB. So if I can find this horizontal difference is, let's see here, it's 1, 2, 3, 4, 5, it's 5, but I can also get that by taking the difference between the x coordinates. So 3 minus a -2 is 5. And the y difference, this length right here, we can count to be 2, but I can also get that from the difference between the y coordinates, which is 3 minus 1, which is 2. All right, now I'm looking again for the length AB, which is, I'll call that x, and I'll use the Pythagorean Theorem, which is a squared plus b squared is equal to c squared. And the most important letter is c, because c is the hypotenuse. So I plug in 5 for a, and 2 for b, and x for c, then I can solve using the Pythagorean Theorem. And x is the square root of 29. Now that was the length AB, so length AB is equal to the square root of 29. So this works really well if you have a graph. But what if you don't have a graph? What if you just have two coordinates and you're looking for the difference between the 2 points? Well, we want to find a method or a formula that would help us find that difference. And there is something called the distance formula. So let's rework this problem, but instead of using the coordinates, I'm going to use x1, y1 for the coordinates of A, and x2, y2 as the coordinates for B. Now, remember that we took the difference between the x coordinates to find 5. Now, instead of 3 and -2, I'm going to plug in what I used before, which is x2 minus x1, which is the difference between the x coordinates. And for y, I did 3 minus 1, but using my new coordinates, it is y2 minus y1. And instead of calling the difference x, I'm going to call the distance d. And I'm going to rework this in the Pythagorean Theorem, now using this as one leg, and this is the other leg. So I know that a squared plus b squared is equal to c squared, and plugging in d in for c, then I find, and plugging in this in for a and this in for b, I find that the distance between the 2 points is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now this is the distance formula, and it comes directly from the Pythagorean Theorem. Now to show you how the distance formula works, let's use the distance formula on a new problem. And let's use the page before lesson 3 on the left-hand side so you have more space. If I give you the coordinates 1, 3, and the coordinates 5, 6, could you use the distance formula to find the distance between those two coordinates? I'll call this one A and B if that helps you out. Now, you could call this x sub 1, y1, x sub 2, y2. But honestly, the way that I think this through is I think about this as the difference between x and this as the difference between the y coordinates. So I think about d as the square root of the difference between 1 and 5 is 4. 4 squared. The difference between 3 and 6 is 3. 3 squared. And so the distance between that is 16 plus 9, which is a square root of 25, which is 5. So the difference between these two coordinates is 5. Next, we're going to go on and talk about slope. So below this, draw a line. And let me remind you that slope is the measure of the steepness of a line. And the slope is measured left to right. So if this is my graph, then this line would have a positive slope because reading from left to right, like you read a book, it's going up. This line would have a slope of 0 because left to right there is no steepness. And this one, left to right, is going down, so it's negative. So that's the basic idea of slope. It's the measure of the steepness of a line. Now let me remind you that to be more precise, to quantify how steep a line is, that we pick 2 points on the line. And we look at the change, the vertical change and the horizontal change, just like we did for distance. And this distance, again, is y2 minus y1, just like we saw with the Pythagorean Theorem. And this change is x2 minus x1. Now, sometimes we call this the rise, and this is sometimes called the run, meaning rise is a vertical change and run is a horizontal change. Now, the formula that's most commonly used for slope is that the slope is equal to the rise over the run, or y2 minus y1 divided by x2 minus x1. So this is what we use to find the slope of a line. So draw a line below that. I want you now to find the slope between the same 2 points we used before, so the point 1, 3 and the point 5, 6. Well, again, that the slope is equal to the rise over the run, or y2 minus y1 over x2 minus x1. Now, this one, you have to make sure you're precise about which one's x1 and y1 and x2 and y2. So the first coordinate is x1 and y1, and the second coordinate is x2, y2. So plugging those numbers in, I have 6 minus 3 divided by 5 minus 1. And what I get is 3 divided by 4. Okay, so for every 4 that it changes horizontally, it'll go up 3. So again, let me draw a picture of that. For every 4 that it goes horizontally, it'll go up 3. And that's the slope of the line. Now, another way to think of the slope is as a unit rate, meaning for each 1 you go over, you'll go up 3/4. You'll go over 1, up 3/4, and that has the exact same effect, because if you do that 4 times, you'll go up 3 in total. All right, this video is about finding distances and slopes in the coordinate plane. Thank you for watching.